Hey everyone, my name is Kajal and welcome back to my channel. For today's video, we are interviewing John and we will get to know a little bit about his journey in robotics. Hey John, thank you for joining us.
Hey, nice to be here, Kajal.
Thank you. So let's start with a little bit of introduction. Can you tell us a little bit about yourself?
Yeah, so I'm currently an autonomy engineer at Skydio, working on the deep learning team. My passion in robotics has been like a really long-term thing, basically since I was a kid. It's morphed over time to now working on drones at Skydio. So I'm working on like computer vision, making sure we don't crash into things, that sort of thing.
Nice. That sounds really fun. And then let's now talk a little bit about college and high school. So you've participated in a bunch of robotics competitions, such as RoboSub and one more, I believe, Vex. Yeah, can you tell us a little bit about what that experience was like and what were some of the learnings that you had by participating in these competitions?
Yeah, the first competition I did, it was like a serious competition, was the Vex competition. So that was in junior year of high school. So that's 10th grade, or sorry, 11th grade. So basically, like the way Vex works is that there's a game that they make up every year. It usually involves like picking up some object and placing it in a goal. So sort of like fancy robot soccer almost. And so it changes every year. So you have to build a new robot. And there's like a standardized kit of parts, which is like super important. There's first, which you can basically use whatever you want. And the end result with first is that the teams that have a ton of money like end up winning because they can afford bigger parts. But for Vex, like all the
Mhm.
parts are standardized. So that at least is like a semi-level playing field. So we started a team, basically started in the back of the physics classroom. And we initially made a big mistake, was that we couldn't convince the school to buy us a field. So if you imagine like sort of like you have a soccer team, but you have no like field to practice on. So you have like soccer practices where you sort of like talk about soccer at a high level and like how you might, score a goal. And we had the object. So we have like the ball, but we can't do like proper practice. We're just sort of like, doing stuff with the parts, like pretending we didn't even have a goal. So it's sort of like, okay, we move it into this position, and then if there were a goal there, then it would probably score. We basically spent the whole season working on this thing. We finally made it to one competition. It was a big effort. Basically by the end, we didn't know what we were doing. We basically thought that we could design this robot, build it, it would like do something reasonable, and then we would go to competition and compete with it. It's not how it works. There were all kind of issues. First version of the robot would fall over all the time. We like kept fixing random issues, avoiding the competition because we thought we weren't ready. We were scared. Finally went to the last one of the season. Stayed up all night till like 4 a.m. It was super nerve wracking. At one point, I like started crying. Eventually, like you get it out of your system, and then like a few minutes later, get back to fixing problems. Went to the competition, got totally demolished. We actually scored negative points. So it's sort of like the equivalent of like if you were on a soccer team and someone on your team goes to score a goal, but you like block it. So you actually,
Oh,
it
okay.
was actually like would have been better for our teammates if we didn't show up at all. But we learned a lot, honestly. Like I think actually that's a really important lesson, is failure is not really a thing. Everything is just an experience that you can learn from. So I actually had a great time despite getting demolished. There's like all kind of robots there. It was really cool. Talked to all kind of teams, just chatting them up, asking them questions. No one perceived us to be a threat in any way, so they were very helpful. We learned a lot, came back from competition, wrote like a 10-point plan. Like, this is essentially all the things we messed up on. Actually, built a second version of the robot. So at that point, we could not continue to the state championship for obvious reasons. So our season was over. We were out for the season. But yeah, I still, we were basically trying to catch up with teams that have been doing this since middle school, many years. So I took the approach that like, yeah, I gotta learn anyway, build the new robot. Tried to convince some teams to scrimmage with us. Nobody wanted to scrimmage with us. Yeah, and
I'm
yeah.
sorry. What do you mean by scrimmage?
Oh, scrimmage, just like a practice match. If you play pickup
Okay,
soccer with a team, it's kind of like that, like the nerdy version of pickup soccer. Yeah,
nice.
we basically just wanted to test out the robot, see if it was any good. But I think it didn't really matter. I think the important thing was like actually, getting into the actual engineering design process, which is iteration, right? You don't just build something and then it's done. Like you have to test it at every step of the way, find what do you need to improve, actually work on those things. Yeah, so spent the whole summer working on that robot. got to a good point. I mean, like we're doing, I think the biggest thing we learned is we should have kept it simple from the start. We were trying to do way too much initially. Just like getting a few parts on the field and like just imagining if you were the robot, like, does this look about right? You know, like validate the design before you build the whole thing, like just see if it's even reasonable. And we also looked at a lot of designs from past years. That was another, you know, in industry, we call this like the literature review. So that's really important. Like you can usually learn something from designs that exist. But that season went really well for us. We kept improving. We ended up winning the state championship actually, which was
Nice.
great.
So like first year
Expected
you
that.
failed, and then first year you went into negative scores, and then
Yeah,
second year you
exactly.
went ahead and won
Exactly.
state championship.
Yeah, it was initially it was kind of tough. So part of the competition is you have to partner up with other teams. You sort of make the team at the tournament. And initially we had difficulty people agreeing to partner with us. In one case, we were actually, so you go through like some qualification rounds to basically score everyone. So even though we were the top scoring team at this point, we were trying to partner with some other guys. And they basically said like, yeah, I mean, the thing is we're more comfortable with a more experienced team. Like, even though, you know, you have all these great wins today. So that was kind of sad. I was sad about that.
Yeah, but very interesting that people are, which I guess in some sense also represents a real world where people, even though you are good at or best at what you do right now, unless you don't have experience, people are not very easy on bringing you on, even in, robotics companies.
Yeah, it's true. And it's something that's frustrating with me in the past. Yeah, I mean, once you even once you feel like you've proven yourself, generally you still have to prove yourself individually. In that case, I went back to my team and I was like, all right, guys, so that team we wanted to partner with, they don't want to partner with us. So we're gonna go with these other guys, and now we have to beat those guys. And we actually ended up beating them. So they never
Nice.
declined a partnership from that point on. That was a mistake on their part.
That's actually very interesting experiences you have. And I really liked what you said that don't think about it as failures, they're just experiences into, the next thing that you're gonna do.
Yeah, for sure. I think in college, on a different robotics team, one of the thing the team captain said was our goal is really just think of it as like all the space of all possible failures, like all possible errors. Like the goal is to remove as many things from that space as possible. Like the more we get the robot to screw up, it's actually a really good thing because at least it's not happening at the competition. You know, in a company, at least it's not happening with the customer. Like it's frustrating. You're debugging your code, you're flying your robot around, like we have flight test all the time. And yeah, things go wrong. And it's easy to get frustrated in the moment. Like I've worked so hard for this and yet it still doesn't work. But it's better, like it's actually a good thing. And then you can get to a point where super reliable, best quality. So
Works time and again.
yeah. And then okay, the sad part of engineering is once that happens, everyone's like, oh, this is good. Now we need to do like version 2. So like just start all over again. And now you're going to have to deal with all the same stuff.
I can totally relate to that. So with that, let's talk about college. I know you went to Cornell. Can you talk a little bit about your experience there?
Yeah, Cornell's a great school. I think it's underrated for sure. Just I think because the acceptance rate is like higher than the other Ivies because it's bigger. But one thing about being a big school is there's like a ton of students, so you can get into really small niches of students. So for robotics, there are actually 3 robotics teams. So many colleges have 0
Nice.
robotics teams. Cornell had 3. So I actually, because I did well in high school robotics, I ended up getting a scholarship to Cornell, which was super big. That was amazing.
Nice.
It really helped me pay for college. But my first year, I actually got rejected from all 3 robotics teams. So yeah, you have to do like basically coding interviews. So I'd never done a coding interview before, failed miserably. I told this guy
I'm sorry to interrupt. So a coding interview for getting accepted to a robotics
it sounds
competition
crazy.
team.
Yeah, so like you get into this selective college, and then to get onto the robotics teams, like the acceptance rate there is still like a few percentage points. Maybe it wasn't anything hard. Let me sort a list, and on the whiteboard, and yeah, I just completely failed. But it's one of those things, right? You practice, you get better. The next year, I underwater robotics team.
RoboSub, right?
Yeah, so we compete in RoboSub. That was CUAUV. That was really cool. That was a great experience. I basically got into computer vision sort of accidentally. So at the time, I was really trying to get an internship and failing like miserably. So places basically wouldn't call me back. And it's actually pretty hard starting out in robotics. So I decided I was gonna work on the robot over the summer. So the competition is at the end of the summer, so some people stay over. So that was pretty great. Got a ton of experience. I ended up working like 2 part-time jobs while I was working on the robot, which I wouldn't recommend. Yeah, I mean, you think like money is good, but time is more valuable than money. Like if I had spent all that time instead, working on the robot and taking out more loan, that would have been smarter. I don't know. At the time, I didn't want to do that. The end result of that was competition went pretty well. I think we didn't do as well as we wanted. We wanted first. We got third. We got beat by Caltech and IIT Bombay. It was really sad because so in semifinals we were like the best by far, but we messed up in finals, and that was my code. So I felt pretty bad about that. But I actually managed to bump into a guy from iRobot, the company which makes Roombas, at the competition. So that's how I ended up getting my first internship in robotics. Is I chatted up this guy, just talking about all kind of how we test, how we're doing computer vision, like feature tracking, all this kind of stuff, and he was pretty impressed. Yeah, I finally got an internship, but it was a long path. Like it was a lot of ups and downs. That was really great. And then the next year I became software team lead, which was pretty great for go over in 2 years from being like rejected entirely to like leading the software team.
And also having an iRobot
Oh
internship.
yeah, and then the internship at iRobot, that was really fun. Yeah, and then so became software team lead, learned a lot about like leadership, management stuff. Honestly, more difficult than being an engineer in many ways. And then we finally won. We won first. So that was
Oh,
nice. That was
nice.
a good feeling.
I
Yeah,
feel
that
that's
was
kind of
good.
been your trajectory, right? Even with Vex Robotics, failing miserably and then going all the way and winning state championship, and then not making the team, and then going and
Yeah.
coming first.
I mean, it's super possible. I think most people don't realize I mean, failure is just an opportunity. Like you should understand why, like what went wrong specifically, right? And success isn't that great either, because many times you succeed and you have no idea why, and then you can't replicate it, and that can be very frustrating. So yeah, I think for sure, like we definitely understood what went wrong. We really messed up with integration in particular that first year, and that really bit us. Like individually, all the computer vision was working together. It was not, and that's essentially why we got third. So yeah, we did early integration, bunch of other things. I really can't take credit like for that win, like except for a tiny amount. Like there's 50 people on the team, and there's like ton of great software people. So I was really doing a small part, but integration definitely was a big thing that we were missing.
That's great. I'm really glad, you were able to take all of those learnings and then combine it towards your success. All right. The last question that I have for you is, what advice would you give to those coming in, either, for robotics competitions or for masters or for a career in robotics in general?
Yeah, I mean, I think the biggest thing that I honestly still struggle with, try your best not to let yourself get overwhelmed. I mean, robotics is very complicated, and that's just like fact. Like I've been like still trying since the first grade, to make robots do things. And but if you think about it that way, like to some degree it helps to not know how hard it is because you don't get overwhelmed. But yeah, I think you should to try to keep it simple. Like, if you're faced with a problem, think of like what's the simplest possible solution, like literally simplest possible, like yeah, and then build that first. We call this the MVP, right? Build that first and you'll learn something. You might not have the best solution. You'll understand what parts of the problem are difficult, what parts of the problem are not difficult, and at least from there you won't be wasting your time. Like oftentimes when you start working on something, you think like I think this part is really difficult. That's what we should be focusing on. And you're totally wrong. Like actually this other thing is the difficult part. This thing is easy. You shouldn't be worrying about this thing. So as soon as like if you can get to a point where you're getting feedback quickly and then sort of revise your approach, that's super key. I think that goes for everything. Yeah. So if you find yourself getting overwhelmed, happens to everyone, take a step back, ask yourself, am I really, doing the simplest thing right now? Go from there.
Yeah, I would say that's great advice, especially when it comes to robotics. Because even I remember when I started out, it's like, oh, there's computer vision, oh, there's machine learning, oh, there's path
Yes.
planning. And you would be like, how am I going to do all of this? And then you have to like just, take a step back and be like, okay, let me do this one project or, one small thing and see, okay, if I like this or not, and then go try something else. Or as you said, course correct and continue down that path.
Yeah, for sure, for sure. I think that's a really important thing. If I had learned that earlier, I think I would have wasted a lot less time. Yeah, and then again, like, people will doubt you. People will maybe not pick you for the role that you want or the project you want at work potentially. Like, there's all kinds of disappointments that you'll have. And that's normal. That's part of life. But yeah, you should always be thinking like, what can I do differently in the future? Like, what is the reason like that things are going wrong? And I don't mean like very specific things. Like, in our first year of the competition in high school, we could have said like, our issue is our robot tips over. Like, and that's true. Like, it did tip over, and that's a really big problem because now you can't do anything. But like, the bigger problem is that why did we get to the point where we've built the whole robot and then we realize it tips over? Like, we should have been doing things before. Like, that shouldn't be the problem the night before the competition. You know what I mean? So you need like the learning there was like about iteration. It was about like prototyping, finding out flaws faster, and keep developing. So I think, yeah, really getting down to the root cause is really important. I think that really sets apart, like, I think some of the best engineers are the ones who can figure out like truly, like, you might be a surface level failure, but like underneath, like, what's going wrong. If you figure that out, you can like massively improve.
Yeah, that's so true. Well, thank you so much for coming and speaking with our audience here and sharing your experiences. I really appreciate how you were so open about your failures, so others can also learn that, hey, it's completely fine to fail.
Yeah, for sure.